Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Rob Manning. Rob was, up to recently, the chief engineer for NASA's Jet Propulsion Laboratory, JPL. Rob has been designing, testing, and operating robotic spacecrafts for more than 35 years, actually 45 years, including Galileo to Jupiter, Cassini to Saturn, and Magellan to Venus and many Mars missions. Rob, welcome to the Future Space.
Thank you very much, Daniel. This is fantastic. It's fun to be here, and I love sharing what I do or what we do because, first of all, public pays for me. I get a salary indirectly from the U.S. taxpayer. So, thank you, thank you all.
Classic. A wonderful job to have. So I'm kind of curious, with all this experience, hypothetically, if Darth Vader needs a new spacecraft, does he pick up the phone and call you?
Oh yeah. He calls me. It's hard to hear through the breathing, but he does give good instructions. No, I've been involved. It's fun to be part of the design side and the operation side, make things happen. It's a real honor to be allowed to do that as an engineer. It's more than a treat. It's a real privilege. Um, but I'm very much focused. When we do designs, we make something new. It's really in the interest of the mission, and so I wouldn't say I'm a generic designer. I design specifically for a particular kinds of mission. So if you've seen things like landers that bounce on another planet, you can think of me. If you see about I've worked on three-legged landers, multiple-legged, several of those over my career, and of course the sky crane system, which sky crane maneuver we called it, which lowered the rover to the big rovers Curiosity and Perseverance to the surface of Mars twice now, and worked like a champ. So you can think of me if you want, because I was deeply involved in those designs and inventions, but they're really fun, and it involves a lot of very creative and capable people.
Well, congratulations to you and your team, because definitely, I mean, the crane, the concept of the crane, the success of the crane, and all the other apparatus of space exploration, it's still baffling to think that we can do that remotely, right? These are concepts that are tested in here on Earth, but have to perform in a place where we've never been in theory.
Right, and we're so far away, and that it has to happen all by itself, and with us, and you see us all in our blue shirts, screaming, yelling, putting our arms up in excitement. We're not doing anything. We're just there to watch, and we watch through the data. But by the time we're yelling and screaming with excitement as it's landing, it's actually landed long ago, because of the one-way light time from Mars. So we're just there for the ride. We really, our vehicles have to be trained how to do that on their own, and it's something that we do specialize in as autonomous systems, and making things that have a sense of autonomy and a little not quite the point of AI autonomy, but to the point of at least being able to trust these systems to do what they need to do when they need to do it. Um, and yeah, by the way, and I have to say, the sky crane looked cool, but we stole all of our designs. Although we came up with the idea of doing it for landing a rover on Mars, with helicopters have been dropping payloads in a very similar manner for many years, and so we're in fact that the name sky crane is a homage to the sky crane helicopter that Sikorsky developed years ago, and so we in fact we even had Sikorsky pilots review our early design concepts to say, well, hey, how about stability and dynamics, and understanding whether or not that kind of thing would actually work. As we often say, we stand on shoulders of giants, and there's been many giants ahead of us that we've been able to, who have willingly let us steal their best ideas and put them to work for us, and graciously have allowed us to do the work we do. And I hope that generations from now, they'll be doing the same with the stuff that we've done.
Well, I mean, Steve Jobs, I think, agreed on that. Genius is the capacity to see solutions in some remote places and apply them to, to your needs. So I think the world has been built on being able, I mean, even Darwin Darwin did not invent, evolution. He actually took it from others, and it was a collective work. He was just the one who kind of was able to manifest it. Um, Rob, there's a lot of things that I want to go back to, but first, before we get there, what would be three words that for you captures the essence of space?
I've been struggling with that question. You gave it to me, emailed it to me, and I've been, the first order, space is nothing. It is the absence of stuff. But we don't think about it that way. That's not how we hold that word in our mind's eye. We think about it as a opportunity to try to boldly step out of our world and away from the world that we evolved in, developed over millions, billions of years, and to try to see beyond ourselves. It's really a way to see. It's a word that brings to mind possibility. So, wonder, excitement, and possibility. That's what space means to me.
When you were talking about nothing and opportunity, or there's a word in Japanese that when I discovered was it resonated so much with me. A lot of my work is, despite the fact that I've never been to Japan, I've always had this connection to the aesthetic and the values. But there's a word, and it's spelled M-A, so ma, and it. The easiest way to explain it is if you throw something up in the air, that tiny fraction, that millisecond where that object is not moving, right? It's a place of nothingness, but of endless opportunities.
Yes.
It's this, and that it's a place where you have nothing and everything at the same time, and that's what it's ma. I'll send you the link
Yeah.
to that
Thank you.
word, but that's what I was thinking about.
Physicists define space as in some sense, as the distance between things, but we're, over, and, people like me who explore space, is something that you must cross in order to get to your final destination. It's not the destination in itself. But it's become so much more in physics, and particularly in the last decades or two. In fact, even for the last century, since Einstein came up with this wonderful general theory of relativity. It's the fact that space is a thing is something we don't really think about. So there's so many different ways to look at it. When I say it's a thing, we talk about the fabric of space-time. That used to be a euphemistic term. It's becoming more real as certain scientists are exploring quantum gravity and understanding the sense of, in many respects, the quantumness of our world, and particularly entanglement, plays a role in defining the very essence of what space is, as correlations between places. And we've known for quite a while that space itself is not empty. You can't possibly empty it out. The Heisenberg uncertainty principle forbids emptying that space out because that would provide absolute certainty of nothingness, which is an amazing idea. And so there are always things popping into existence at the smallest level. So even nothing is something, which I think is very inspiring to me because it says that there's always something. People whose brains wander into the space of nothingness, people who feel, is that all there is to life? Isn't there something more? There is always more. The moreness of our universe is hard to understate. And so I think it's easy to, in some sense, oversimplify our view of the world, our philosophy of the world, by even using the word nothing.
When I was thinking the nothingness, like often when we talk about meditation, many people interpret that as getting rid of tension, getting rid of the disruptions. And for me, I have a really total take on it. It's not the absence, but it's the balance within those tensions, right? You don't want to take them out. They're never going to go away, but you want to find the stillness within them.
Well, and what I love about meditation too is because, especially in my world, so much of what I do involves rumination of your imagination. You, in some sense, you are closing your eyes and you try to imagine some sort of future, and you're trying to put it in sort of space, into sort of context in your mind's eye. You're building something up, and you are actually far, far away from the here and now. I mean, literally, when you're building a mission that's going to go to Mars, how much of your time are you actually on Earth? In our mind's eye, we are always on Mars, or going to Mars, or landing on Mars, or doing something to get there. So in some sense, we are becoming more and more disconnected from this beautiful planet that we live on. So one of the things that what I love about meditation is that it actually brings my attention and focus to a very important point: the the now, this absolute moment that we are in at this present time. And it's so easy to forget that we only live in the present. We don't exist in the past. We don't exist in the future. So in many respects, my work takes me far away from the now, the present, and the realness of life here. So I have to do that forcibly, get my brain to a spot of, well, let's think about the here and now and think about it. Now, that's not always a problem, because oftentimes we have if I'm in the midst of testing a vehicle and doing a test right now, and I'm super focused on what's going on right now, then I will have that sense of time. But most of the time, we are far and away from this planet when we're thinking about doing our work, designing these systems and making them work for some abstract future that may or may not come true, depending on how good we are at our jobs.
Rob, as an engineer designing spacecrafts for 45 years, obviously you understand the technology story of space, the engineering aspect of it, working for NASA, the science story, what we do and why we do it. But now I think we start a new era where science and technology might not be at the center of it. What would you think of, what is the human story of space?
Well, the human story, it might say, one of the things that frustrates me about some of the work we do is that, in some sense, because of the mechanics of the work we do, and in fact, we're spending taxpayers' dollars, a lot of things we do is about the mechanics of doing the work, and in some sense, the process. Now, process is wonderful. It helps make us more efficient. It makes people understand quicker, because we could just do it the way we've done it before, or set it the way we said it before. But ultimately, it's so easy to forget that all of this is a deeply humanistic enterprise. Even the work we do, where we're going out for science, we take the science high-level requirements and we break them into science observables and flow down to functional requirements, down to the various elements of the system, and turn the process and turn the crank. It's all well and good, and it's very good, because we, as humans, we're error-prone. We need to, and doing this keeps us from forgetting to do important things. But ultimately, we are trying to answer questions about us, and even the most arcane questions about, for example, the two Voyager spacecraft. They're going in opposite directions. They're the furthest human-made objects overtaken the Pioneer spacecraft. They're way out there. One's going up, one's going down. They're looking for where the influence of the sun stops outside of our solar system. How much wind from other stars interact with the magnetic field of the sun, which extends far out. And so that's very abstract. So how does that influence me? What does that say about me? Well, it turns out even things like that have an influence, because we're learning that it's very possible that in the past, the trajectory of life itself may have been altered by the passage of nearby stars in our Milky Way that have gone relatively close to our our solar system, and has affected our magnetic field, and even has exposed our little planet to far more of the dangerous radiation environment from deep space, from the galactic cosmic rays and other particles that rain down. We keep forgetting that we have a nice little force field around it, just like Star Trek. We have the sun actually protects us with this magnetic field. We have our Earth's magnetic field protects us. We have our oxygen atmosphere, which wonderfully near the top converts the O2 to O3, ozone, which then produces a shield of ultraviolet light protection. So we are happy living our little planet here. This must be a safe universe. Well, it's actually not that safe outside. And so us going out there, we may learn something about the own history of life on this very planet by exploring the deep darkness and coldness of deep space, far beyond our own solar system. So there are little things like that, just these connections that we make. You know, we've learned so much about our own planet, about ourselves, about our own history, by looking out there, because it puts who we are and how lucky we are to exist at all in perspective. And I think that perspective is both, at one level, very terrifying and humbling. The other hand, it's incredibly wonderful. It says that you know, we are much more lucky than we have a right to be. We are very lucky to be alive. We're very lucky to be doing what we're doing right now, communicating to each other via abstract ones and zeros that are communicating across this abstract internet using digital equipment, some of it, much of it, developed for deep space, and so deep space exploration and our spacecraft. So it just feels like, you know, how lucky are we that we can actually have this kind of a conversation at all? I just find that to be thrilling.
You said something that I had never thought about, because we never see it in that way on TV or anytime it's explained, that both Voyagers are going in opposite direction.
Yeah.
When you sit on TV, or when you sit even on a magazine, National Geographic, they will show the two kind of similar trajectory or similar path, but they're going in opposite direction.
Well, it's really hard to draw them on a piece of paper because it's three-dimensional. So one's going up, one's going down, and they're really far apart. The irony, check this out. This is a geek transition here. I'm going to tell you here. I don't know if you heard that. First of all, Voyager 2 last year suffered it's not quite in as good a shape as Voyager 1 in terms of instruments, but they're both getting long in the tooth. They're getting old. They're 1977. They're launched using 1970s technology. Now their cameras aren't working anymore. We've had to turn them off. They're very cold. There's hardly any power left to operate them. They're using what's left over plutonium to keep them warm, keep them from freezing, and produce a little bit of electricity to operate it. Anyway, the Voyager 2 was having some trouble, so we struggled, and we brought people back. I brought some of my old colleagues back who had worked on it. And so what happened was, we sort of had to fix it, and we said, we need to fix Voyager 1. And do the same thing, fix it, because we found a little design flaw that made it go kind of a little bit nuts. So that was last year. So we were about ready to fix Voyager 1, and Voyager 1 suddenly, to our dismay, went crazy. And going, what the heck? We started hearing it was still alive, but it was going blah, 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 just garbage was coming out. In fact, mostly zeros and occasional ones, but it was not very easy to understand. What do we do? We don't have a test bed here on Earth. We don't have a copy of Voyager on Earth. We don't even have a software simulation of Voyager on Earth to try to see if we can figure out what's wrong, or figure out how to rewrite the software and fix it. It's not telling us what's wrong. It's putting this garbage. We had a team that worked and tried out various things, and we finally figured out what was actually wrong with Voyager 1. And for a while there, we've been using, in fact, we did this the first time with Voyager 2, we were using the other Voyager as a test bed to test the ideas out on the other. So we have basically our test bed, one test bed is way up on one side, north of the solar system. The other one is way down south on the other side. And we're using each of these test beds, these vehicles, to test each other because we don't have one here on Earth. So this is probably the most distant test. Well, it's without doubt by far the most distant test bed we've ever seen or ever used on Earth or anywhere. And but it worked, and we got it working. And so sometimes we got very lucky that we got it working at all, but we did finally.
It's just incredible. But there's this idea that I have been wanting to write about it, but about the human cost of exploration and seeking knowledge will never be the same as it was before. Because back in the days, if you wanted to find out something, if you want to learn something, if you want to explore new places, you physically had to find it, right? If you want to know the weather in Antarctica during the winter, you had to go spend the winter in Antarctica, and then you had to die in the process. If you want to know if Greenland was an island or a peninsula, you had to walk around and find out, among the polar bears. Now we have a drone on Mars. We have rovers on Mars. We have satellites. We have machines that we've designed to collect that information and find out, and give us all that we need, so that when we show up, it's never going to be, this is all new. There's still a lot of risks involved, but we're not showing up blindsided. How excited do you feel about this new era of exploration, where humans are not taken out of the equation, but we've kind of taken away some of the barriers that makes it more dangerous for us, and we can kind of send our scouts, and then after that we follow?
It is different. There's no doubt. And there's nothing like exploring a dangerous part of Mars during the day and then going home to your wife and family in the evening, having dinner. It's a lot safer for us. There's no doubt about it. But there is something, a lot of people I have this view that we're sending these machines out and they report back, and we just read it and write papers on what we see. It's much more, I think it's much more like, we live far more vicariously with these machines than most people realize. We're actively involved in deciding where they go and how they move. We see what they see. When a robotic arm reaches up and touches a rock or drills into rock, it's our actually left arm, because they're lefties, going in and touching the rock. And so there is a real sense of us being there and being very present with these machines. It's not just simply a matter of, you go out, let us know how it goes. We are really interacting very much so, even though they are autonomous. They are, when we do our driving, for example, we don't drive while the rover's driving. We drive well in advance and try it out on a three-dimensional scene and find something we think is safe enough. We give hints to the rover, say, hey, rover, this is the route that we kind of recommend. Good luck. Let us know this evening how it goes. And it will send back all its messages, the images, the pictures. And we find out, hey, it pretty much followed what we told it to do, but it changed its mind a few places and did some other things. And then we played back what it did. It's like, we didn't see that rock. Oh, we didn't see that hole. So I'm so glad you're so smart, rover. And but there's a real sense of us. Think of it this way. Think of a support team for a group of explorers to Antarctica who are marching through, but you have an intimate support team, kind of mission control, back at the home base that can actually interact, make suggestions, and then hear back from the team of what they're going through. It's true. It's not nearly as dangerous. There's no doubt about it. In fact, think about it, especially we're trying to finish up a vehicle that's supposed to launch in just a few months, on its way to orbit around Jupiter and eventually do these flybys of Europa. There is no way that any human will ever go there without a death wish, because it is a place that is guaranteed to kill you. The radiation environment is so severe at Europa, this wonderful icy moon of Jupiter, that you would die very quickly after you're swinging by. You wouldn't have time to even land before the radiation would get you. So these machines really do expand us. Think about this. We have telescopes, we have binoculars, we can see farther. Ooh, look at that. When you're exploring something, you don't always, it's not always in your face. Sometimes you are there, but you're not really there because you've brought things with you. You've extended your eyes with binoculars. You've extended your views with telescopes. You've extended your reach with long arm extensions as you reach that hot rock of lava rock with a special tool. In all cases, you are there, but you're not quite there. These machines that we're creating are elaborate extensions of us as humans, and it's sort of a natural step that's been part of the progression of exploration since its inception. People didn't swim across the oceans. They had machines to help them. They try to make it comfortable, but they brought food with them. We tried to make the art of exploration really was about trying to get as much as you can with as least risk as you possibly can make it. And I think that's still true today.
There was a question that's been in the back of my mind, and you just kind of created the best. I mean, a segue for me when you said swim, across the ocean. Many people say that comparing space exploration to ocean exploration is totally wrong. You can't compare the two because one is our element and it's not a big deal. And now you're talking about space, and space, we can kill you. My response usually is, well, you can't compare the past with your acquired knowledge, right? You have to look at what oceans represented back in those days. They went out, they had no idea of the latitude. So many people died. Do you think that where we are, space exploration, is really nothing different than where we've been in the past? It's just that for us, it's our impossible, and it will become possible at one point, right? We'll look back and go, oh, they just didn't know about this and that.
I think that's quite possible. I worry that it's expensive to do this, and once we figured out how to make large steam-powered ocean liners, the costs of and enlarge them, the costs of getting people across the oceans dropped precipitously. Likewise, and then the air travel has done the same thing. Has brought us to the point where it doesn't seem to be a big deal now to say I've gone across to the other side of the world. It's like, oh, you did? Okay, good. What'd you do last week? Oh, you went across to India. Oh, how was that? I mean, think about it. It's incredible. It's made our planet very small. The problem is, we talk about exploring space. Well, we don't actually explore space that much. Voyagers are exploring space, definitely. And when we send our vehicles across, we basically ignore space, and we're trying to find out about Mars. We need to be there, and so I think that people forget that those distances are really vast. It's the laws of physics aren't going to make the distance traveling that ride any shorter than about what it is for us for robotics. At about 7 to 11 months in a one-way trip. A better airplane isn't going to make it a lot faster. Now they're talking, well, there's nuclear propulsion, you could do that, but then the challenge, yes, you can speed up and actually get some more acceleration and continue more powerful rockets to go faster, but then you have to slow down on the other side, otherwise you hit Mars too fast or you just pass it. But even then, it's still many, many months of journey, and there's a lot of technical challenges. So I think it's going to be a while before. So the question is, if ever, possibly, yes, very likely. Yes, likely we will be inventive and find a way to do it. It's like saying, yes, an artist will paint the most beautiful picture ever painted.
I can try to imagine, back in times where you had a horse and that's all you had, right? That there was nothing more. And then sometimes, one person would ask that, you're in that time. There's going to be a day where you're going to have these flying machines that fly, halfway across the world. And just the concept of like, wait, if you go so fast, like it must be so complicated to stop, or how does it, like the law of physics from that perspective, when you're riding on a horse is really different than,
Well, But the other hand, even those days, there was people who were smart enough to know that there were birds that would travel vast distances, passenger pigeons, the communication pigeons that we use. There were existence proofs, in effect, of that vast improvements were possible. We just don't have that yet for space, if you know what I mean.
We don't have any birds that are in the sky that we can see and we can say it exists, so we can do it.
Right. It doesn't mean it doesn't exist. It's just that you could do the math. I mean, Leonardo da Vinci, Leonardo really did the back of the envelope calculations. If you get something big enough, the air gets really thick, and you could use it just like a fish swims in water. You could swim in the air, and just that we don't have anything. We don't have that kind of anything like that for us. It's just something that's hard. I don't mean to be too negative, because anybody who says it's impossible will obviously be proven wrong. Odds are good that they'll be proven wrong. I did the math, and I was very skeptical that you could ever fly a helicopter on Mars. I did this math back in the 90s. Mid to late 90s. And I go, there's no way we'll get a helicopter to fly on Mars. They're just way too much, Well, I didn't realize that the miniaturization of electronics, I should have recognized Moore's law, and showing that the amount of stuff you can package in a small small size, is going up and up and up. So you can get more intelligence and more capability, and make little tiny motors, and make things extraordinarily light, and have it operate at low temperatures, and make more efficient batteries that are even better. So had I known, if I had used my crystal ball with a little more precision, I may have been able to predict that, a helicopter might be possible someday, but it just seems so out of reach. But at least in that case, there was laws of physics that I could point to. I can't point to laws of physics other than nuclear power, nuclear propulsion, that gets those distances any less. However, they're great things. What's cool about Mars? Mars doesn't have a lot of debris like we have here. We have a lot of junk floating in. This is not a great place to put a space elevator up. But Mars is not a bad place. So maybe what we'll do is we'll come up with a way, to find high-speed nuclear propulsion, and then have stop in aerosynchronous orbit, which is like geosync, and then get on an elevator and ride down to the surface, and have that be your kind of in and out plan, and we'll see what happens from there. And it's, who knows? There are possibilities. We just have to be thoughtful and work on them.
I really don't want to dismiss all the problems that we have on the planet, and currently even more so. I mean, it's hard, to look at the immediate. It's also one of the most exciting times, because I personally feel that we're just about to open a door that's going to lead to an entire new understanding of what is possible, right? That leap that is needed to do will create an entire new reality.
Absolutely. I mean, I've been talking to some friends recently about, one of among the problems we have is we have 1/5 of the Earth's is land mass. There's only so much space. In fact, there's as much land mass on Mars as there is on Earth. But we have to mine that to get things like minerals for advanced batteries. We have to convert energy from the sun through the atmosphere and use it into operating our light bulbs, as well as this vast amount of computing resources we're putting together. But we're realizing, it turns out that we could fairly easily transport asteroids tilting near Earth and construct very large solar panels and power and even maybe manufacture massive data machine. So our computing capability, which is taking up enormous amount of electricity and heat and dissipating heat on this planet, and dissipate that out in deep space where it sees mostly 3-degree Kelvin in all directions. If we can find a way to lighten Earth's load and do less of what we need to survive as a species in outer space, we could be doing the Earth a great service and doing ourselves a great service. But we need to figure out how to make that happen. And you're absolutely right. This is we are in a revolution in access to space. Innovation is the rule, not the exception. People are coming up with new ideas. We're using the best technology that we have today and developing new technology. I mean, think about it. Space originally, the advent of space exploration, even in the early 60s, was a powerful motivator for developing technologies. The reason we had miniaturized semiconductor transistors for transistor radios that showed up in the late 50s. So it's because of a push by organizations like NASA to develop those technologies for space applications, because we needed things to be light, low power, and efficient. We did the same things. The cameras that you see in the back of on your cell phone, that active pixel sensors that they were called when we first came up with them, were developed for space applications to make lightweight, small spacecraft that we could afford to launch, because the cost of launch was so high. We had to come up with a way to lighten these technologies. So we're seeing a similar kind of a space-driven collection of innovation, which is really wonderful. I mean, these lithium-ion batteries that we're so used to and have really revolutionized us in ways that people still haven't really quite appreciated, was developed in the 80s and early 90s with money from NASA and the Air Force in the interest of getting more reliable, longer-lived spacecraft. So a lot of this technology has dual use, and we just can't seem to find our ways to create that same kind of innovative environment without that space exploration being there. And so innovation is a key part of this. And it's really, as an engineer, it's a wonderful thrill to watch. It's so wonderful to see people come up with idea after idea after idea and layer on. Some of these ideas will work. Many of them will. Some will, won't, some won't. And it's just fun to watch. And I just love seeing that kind of creativity, because I think a lot of this creativity is being reapplied back to Earth. For example, high efficiency solar cells being used for homes. Large battery banks that are used to level off the energy we use throughout a 24-hour cycle, also being developed for this use for space applications. It's really wonderful to see. I think what we need is resources. And I think one of the things that the space can do is, especially with asteroid mining, it's still uncertain as to what we might get from asteroids, but all the data that we're collecting, including Bennu and other the OSIRIS-REx mission to collect samples from comets, say that these places are really rich and complex, and there's a lot of amazing stuff out there. We got a mission called Psyche that's headed out to the asteroid belt to look at what might be a failed main planet, or a planet that somehow got damaged, and we may see the heart of that iron core of that planet close up. That iron core is incredibly valuable. If you could bring it back, I mean, it'd save a huge amount of time and energy. We could use some of that stuff to do the kind of work we need to do in space. It'd be wonderful to take advantage of that. So it's very exciting.
That vision of the future that we have on Earth, right? That vision of electric world with everything is battery and not fossil fuel dependent. If we want to accomplish that vision, space mining is going to have to be part of it, because the problem on Earth is not the resources. We have plenty of resources. It's the extraction of those resources and where they fall. It's the energy required, the politics, who has it, who doesn't, and the labor laws and all this. And one of the things that I've written about is, I mean, we take it for granted, but up until recently, where you lived, you had to create your own energy, you had to create your own food, you had to take care of your output, everything that you were doing, because you couldn't outsource and you couldn't export any of that, right? So, but now a house is a place where you can just enjoy your backyard. You can make it pretty. You don't have to worry about anything, because everything that you need comes from somewhere else, and everything that you do goes somewhere else. And Earth, one of the things that I see about space in the future is the raw material that we need. Once you can outsource it in places that are barren and arid or non-existent, I mean, not that they're devoid of anything, but the impact is definitely less than here on Earth. Then Earth can be just more of a place where people live and not extracted.
It could happen. It's going to take a while. Creating an environment of innovation is really essential. People say, well, we can't rely on engineers and science to solve everything. That's correct. But it was basically science and engineering that both did two things. One, it completely changed our lives. It made our lives safer. It's easier to be a human now than it's ever been. Its entire 2+ million year existence, and yet at the same time, we've had these adverse side effects we've seen from excess fossil fuel use and extraction, and what it's done to our atmosphere. And I think there's a lot of things that we need to do to. I mean, obviously there's things to do it, but thinking the long term and thinking about how to come up with an equilibrium so that we can survive and somehow live in a way that we find comfortable, at the same time be able to curate our planet, is something that I'm very glad that so many people are involved in that, making that happen. Particularly young people are making that as part of their career choices. They're finding it difficult. It is difficult to solve this problem. It requires millions of people thinking and using their innovative skills in probably equal number of areas. So I'm actually very optimistic. I think we are smart enough as a species, if we let ourselves not get distracted by our politic of our world and start seeing each other as not as enemies but as friends, as people who can inspire each other. I think the world will be a better place. We only have ourselves to blame if it doesn't work out. Can't point our fingers anywhere else, but we can.
It's long term is such a hard incentive for change, right? And in fact, we're the only species who has an understanding of what long term is and what like our agency towards it. There are no other, and that's the one of the challenges, even within us, is that in terms of evolution, we were never wired to worry about our actions, right? There are no other animals or organisms that do something and then they go, well, let's think a second of what's going to be the impact. Every single animal or organism left to their own device will destroy their environment if there's nothing to stop them.
That's right. Somehow or another, we evolved a brain that allows us to do more than what's actually required of it, and including our ability to see forward. And I think this is why it's so important for us to capitalize on our native intelligence that somehow we managed to get. Let's use it for problem solving that we need to do. I've been a big fan of SETI, searching for extraterrestrial intelligence, looking for out there and hoping that there will be someone nearby. And I do think that the possibility for extraterrestrial life, living things, is very, very high. Perhaps even as high as being in our own solar system or other places, such as underneath the ices of Europa. But I think that it's quite possible that intelligent creatures that can have this kind of thoughtful, long-term conversation and have the agency to worry about these things are few and far between. And it may be that we may be the only one in our solar system, in our galaxy, that has this ability. So think about that. In some sense, we are made up of star stuff. We are made of the stuff of the galaxy. And yet somehow this amazing sequence of events have evolved that have given us an ability to actually think about and ponder our place in this vast universe. And I think it's an incredible responsibility we have, not just to our native planet, but I look at life. I think of all of us as being part of this giant web of life. People love to put people on top of the pedestal. We do have some features that other creatures don't have, but we're not that far ahead of them. We're not that far ahead of them, and we're so interconnected as a biological system. I think this web of life extends beyond our planet. It may not be directly descended, but the laws of physics apply the same everywhere. I do think we'll see, hopefully in my lifetime, more convincing evidence of at least biological activity of some sort outside of our planet. And I think that extends throughout perhaps the whole universe. Probably it is, but certainly in our galaxy, I think in some sense we have a responsibility to that web of life. Ironically, even if they're not here, even if they didn't descend from the same genetic sequences that most of life on this planet has descended from. So I'm excited to see us capitalize on what we have somehow been miraculously given, a sense of agency and ability to make a decision about who we want to be when we grow up.
This conversation could last for so long. I totally agree with you. I think that as we venture out in space, we will find a lot of life. I think that life will be common, but intelligent life is different. Like just even here on Earth, we know that life can exist for hundreds of millions of years without having really intelligent life. I mean, if it wasn't for the asteroid doing a restart on the planet, most likely the dinosaurs would still be around because they have been around for hundreds of millions of years. But the last 65 mammals have done more. So we could travel in space and find life everywhere, but that intelligent life. And we do have a responsibility. We are nothing in the big scheme of things, but at the same time, we have a tremendous responsibility because we're the only species that we know of on this planet that is about to take life beyond and continue. And I don't want to say that life as an entity needs to, wants to connect, but I don't believe that the nature of the universe is different than the nature here on Earth. The force to connect and the complexity, the growth in complexity, entropy of going from a single cell to multi-cell and growing in complexity for billions of years only to be limited on a tiny speck in the giant universe would be a failed achievement, right? If you're putting that much of energy only to be destroyed and without option B or C, we are about to take it beyond and continue and assure at least, the continuity of it. And so
you're absolutely right. And we have that capability. The question is, do we have the will? Do we have the intelligence? Do we have the wisdom to do that? And I think that's going to be something that we're over the next decades, we have to really work hard to find in ourselves.
Rob, you've 45 years dealing with the impossible. Right? We haven't gotten into your journey and we haven't gotten into some of the big lessons, or maybe this is now the place for that. But 45 years, you used to be the chief engineer. Now you're adjunct. You're kind of the cool old guy that the young guy go and talk to. If you had if you had to give everyone that comes to see you 3 words of wisdom, what would be Rob's 3 words of wisdom?
Don't give up. Don't give up. There is so much to, doing hard things requires incredible perseverance and struggle and curiosity and connectedness. Oh, there's a whole bunch of pieces that go with that. But it is so easy to feel daunted in this world. Don't feel that way. We got to this point because human beings, do have patience, and they can show amazing patience, more patience than our technology seems to imply when all information is delivered in 5-second TikTok videos. I think we should recapture and rediscover that perseverance and patience and patience with each other too, and tolerance of each other. It requires slowing down, meditating perhaps, and thinking about what it takes to get there without being too easily daunted by the task at hand.
This is who we are as this species. I mean, we're not a bad species. We're a successful species who figure things out. We just need the right incentive. I think we're too quick to emphasize on the negative aspect of who we are, which I think comes back and bite us in the rear, because if you keep telling people that they're bad people or they're a cancer on the planet, well, they will become the embodiment of what you're trying, what you don't want them, as opposed to encouraging people to find solutions and to make it work. And I've written about the difference between can and can't, and work and doesn't work, right? Can and can't doesn't go anywhere. It's a statement that has no longevity. It's an affirmation, and it's singularity. Like it just exists in this little void. Work doesn't work. It's a dynamic relationship with the world, and it's understanding that you just have to continue figuring out until it worked. And the big kicker in all this is that it can work today. It doesn't mean that it's going to work tomorrow.
Right. Absolutely true.
Rob, thank you so very much.
Daniel, it's a pleasure. Thank you so much for inviting me. Enjoyed talking with you. What a great conversation.
Well, I'm looking forward to see what next chapter calls you. It's going to be your desire for engineering and tinkering and achieving the impossible. Now that you're the cool guy on the campus, I'm pretty sure you'll find other outlets.
I will. Thank you very much.
Excellent.
Bye-bye.
Thank you. Bye-bye.